So this is section 5.5, which is on confidence intervals for the difference between two proportions. So let's first start by recalling central limit theorem, which states that Px hat, which is the estimator for the success rate for the experiment X, this thing approximately has the normal distribution, with mean being the true value of the success rate and the variance being P times 1 minus P over N. Now, if we have a different experiment Y, we can draw the same conclusion. So Py hat also has a normal distribution. Now, if you want to investigate the difference between these two success rates, we want to be a little careful here, because when we take the difference of two normal distributions, the new mean is going to be the difference between the two original means. However, the new variance is actually a sum of the two original variances. So you want to be a little careful here. But now we have this, then we can construct any level of confidence interval we want. So we can construct the confidence interval for the difference of the success rate. So we have Px hat minus Py hat plus minus the famous number C alpha over 2 times the square root of the variance, which is the entire thing. So because we usually don't know the true values of Px and Py, so here we use Px hat and Py hat instead. Now, if we remember from section 5.2, the textbook uses some sort of modification to improve the confidence interval. And we are going to do the same thing here. So I want to emphasize that this modification is only in our textbook. So it's not used by everyone. But because it's used by our textbook, you have to use it in homework, quizzes, and exams. So the modification goes for n's and the value of p's. So nx tilde is the original value of nx plus 2, and ny tilde is the original value of y and y plus 2. And px tilde is going to be x plus 1 over nx plus 2. And py tilde is going to be y plus 1 over ny plus 2. So remember in section 5.2, we're adding 4 and adding 2 instead. But now, because we have two experiments, so we're adding 2 and adding 1 instead for each of the experiments. So you can think of, we add 1 success and 1 failure for each of x and y. All right, so now we have this formula. We can do an example. So let's say there's a really hard exam and we have two different teaching methods. We have the old traditional teaching method and the new innovative teaching method. We want to see how much better the new teaching method is better than the old teaching method. So we randomly sampled 98 students for each of the methods. Now, among the ones who are taught using the old method, 65 of them passed the exam. And among the 98 people taught using the new teaching method, 87 passed the exam. So now we have enough data to construct our confidence interval, but first we need to find the values of p tilde and n tilde. So n tilde for old method is going to be 98 plus 2, which is 100. That goes the same for new method. It's also 98 plus 2, also 100. And PO tilde is equal to 65 plus 1 over 98 plus 2 is 66 over 100, which is 0.66. And P new tilde is 87 plus 1 over 98 plus 2, which is 88 over 100, so it's going to be 0.88. So now we can construct our 95% confidence interval for the difference of success rate. P new minus P old. So before the plus minus, we will have 0.88, which is P new tilde, minus 0.66, which is P old tilde. And because we're talking about 95% confidence interval, the coefficient is going to be 1.96, as always. The square root, and the first term is going to be P new tilde, which is 1.88, times 1 minus that, which is 0.12, over n tilde, which is 100. Same thing for the second term. So 0.66 times 1 minus 0.66, so it's 0.34, over n tilde, so it's 100. And using a calculator, this is going to be equal to 0.22 plus minus 0.1126. If you write it in terms of interval, it's going to be 10.74%, comma 33.26%. So this is our 95% confidence interval for the difference of success rates. Well, this means that we are 95% confident that the new teaching method has this much higher success rate than the old teaching method. In particular, that means the new teaching method has at least 10.74% higher success rate than the old method. All right, so this is for section 5.5. Thank you.